Hello, my name is Randy McClure, and I'm an investigator with the U.S. Chemical Safety and Hazard Investigation Board, the CSB. I'm here today to talk to you about the chemical sodium hydrosulfide, also known as NaHS or NaSH. Since 1971, incidents involving NaSH have resulted in at least 32 deaths, 176 injuries, 351 medical evaluations, and 10 evacuations of plants and communities. In January 2002, NaSH was the chemical involved in a serious incident at a pulp and paper mill in Alabama that killed 2 workers and injured 8 others. The CSB investigated the root causes of this tragedy and issued its final report later that year. In July 2004, the CSB issued a safety bulletin to increase awareness of the hazards associated with NaSH. The bulletin outlined specific safety practices to protect workers and the public from the hazards of this chemical. NaSH is relatively safe if handled properly, but dangerous if it is not. In water solution, it is highly corrosive and can cause serious damage to the skin or eyes. The most serious hazard occurs when NaSH is heated or mixed with acid, causing the release of large amounts of deadly hydrogen sulfide gas, or H2S. NaSH incidents often involve a spill, leak, or inadvertent mixing of NaSH with an acid, inadequate engineering controls, such as ventilation systems, lack of detectors for H2S gas, lack of personal protective equipment, and inappropriate emergency response actions. Let's take a look at the physical characteristics and uses of NaSH. The production of NaSH includes combining H2S with caustic soda, and it is sold in both solution and flake forms. In 2003, total U.S. production of NaSH was approximately 269,000 tons. It is used in a variety of industries, including pulp and paper, leather tanning, and mining. When mixed with acid, NaSH releases H2S, a flammable, colorless, toxic gas that has a very distinctive rotten egg odor. The health effects of H2S range from headache, nausea, dizziness, and shortness of breath at lower concentrations to severe lung damage and respiratory paralysis at higher concentrations. Brief exposure to very high concentrations of H2S or prolonged exposure to lower concentrations can be fatal. The average person can smell H2S at low levels that are relatively safe. But as the concentration rises, H2S deadens the sense of smell, making the odor more difficult to detect. This is called olfactory fatigue. Without the ability to smell H2S, workers can quickly be overcome by a release. From reported data for the United States from 1971 through 2004, the CSB identified 45 NaSH-related incidents in 6 industry sectors. Pulp and paper had 14 incidents. Transportation had 12. Manufacturing accounted for 6. Leather tanning 5. Refining 1. And other industries experienced a total of 6. The causes of the 45 incidents fell into the following categories. Improper mixing or transfer of chemicals accounted for 15 incidents, which is approximately 1/3 of all the incidents we found. Spills accounted for 12, mechanical failure 7, improper maintenance or repair 6, and 5 were from unknown causes. We've talked about the hazards of NaSH and the findings of our investigation. Now let's talk about the safe handling practices necessary to control these hazards. Good safety management requires identifying and evaluating hazards during initial process planning and design, and also when existing processes are modified or changed. Processes should be designed to prevent NaSH from inadvertently mixing with acidic solutions. The potential for human error during handling should be identified and eliminated where possible. And process sewers or wastewater systems should not be overlooked. These are places where NaSH commonly mixes with acid. When hazards cannot be eliminated through process design, secondary or backup measures must be used. For example, handle and store NaSH safely. Communicate hazards to employees through MSDSs in regular training. Provide potentially overexposed employees with personal protective equipment, such as chemical protective clothing and respiratory protection. Provide personal H2S detectors with audible, vibrating, and visual alarms. Install stationary H2S detection and notification systems. And test the air in confined spaces for oxygen and H2S before entering. The hazards associated with NaHS require employers to establish facility-specific safe handling and storage practices and procedures for both employees and contractors. Effective emergency response is crucial to saving lives in an incident involving NaHS. In the event of a NaHS spill, great care must be taken to contain the spill and prevent contact with acids. If there is evidence of an H2S release, emergency responders should take the following actions. Restrict access to the spill or release site. Decide whether to evacuate or shelter in place. And conduct continuous downwind monitoring. Special safety precautions should be taken when fighting a fire resulting from contact between NaHS and an acid, since toxic H2S gas may be present. Remember that H2S gas causes many unnecessary deaths and injuries among would-be responders and rescuers. If persons are exposed who do not have the training and specialized equipment to respond to a release, they should evacuate and immediately sound the alert. In conclusion, with adequate precautions, NaHS can be handled safely, but 32 fatalities and 176 injuries, as we found in our study, represent a serious and preventable toll from incidents involving this chemical. To view our written safety bulletin on NaHS, visit our website, csb.gov, where you can also find other information about chemical hazards in the workplace. I'm Investigator Randy McClure with the U.S. Chemical Safety Board. Thank you for your interest and commitment to safety.